Alright, so in this video what I want to show you is how to do the grain size distribution test or the sieve analysis test. This test consists of two main parts. One is to test the coarse parts of the soil, and the second part is to test the fine grain portion of the soil, right? In order to do the two tests, so mainly the sieve analysis test and the hydrometer test, the first thing that we'll need to do is to grab a bulk sample of the soil that we want to test that contains of the coarse and fine, everything as is. We'll take or grab about 1 kilo of the soil that we want to test, place it into a bowl. The first thing that we need to do is to do the wash analysis. And during the wash, what we want to do is to grab, through rinsing water inside the soil, grab all of the fines contents or the fine portion of our soil. So basically anything that will pass through the number 200 sieve, right? We want to grab all that separated from the coarse particles. Then when we do that, we'll test the coarse particles through the sieve analysis or the sieve shaking, and we'll test the fines parts of our soil through the hydrometer test, right? We can't combine the two and test them all together. So here's my 1 kilo of the sample that I want to test. So you can see that there are some coarse particles, there are some fines in there. The general color of the soil is light brown. And you'll see various amounts of rounded or sharp rocks in there also. This little thing here is one thing that could actually show you these main different solid particles. So you have gravel that's above 4.75 millimeters, and then you have these coarse sands, then you have medium sand, which is a little bit finer, and then you get into the fine sand, which is very, very fine. The bottom two are probably more what you would see when you go to the beach, right? So the medium sand and the fine sand is very close to beach sand, actually. Okay, so and then you have the coarser stuff on top. Anything finer than that will be considered silt and clay. You'll see a little bit of silt down here, very hard to distinguish, but if you look very, very closely, you might be able to notice the difference. So my idea here is to grab portions of this soil and then wash it. And basically what I'll do is grab the fines parts with water. They will all go, I'll be collecting them into this bucket that you're seeing here, right? And this is my number 200 sieve, right? This is a very, very fine sieve that you're seeing. So the designation is right here, number 200. And the size of the opening is 75 micrometers. So I'll place that on top here. I'll grab with my spoon. So I'll grab a spoon of my soil here. I'll place it into the number 200 sieve just like that, and I'll start running water. Not a whole lot of water. So the idea here is to add some water, and as you can see at the bottom, you're seeing a little bit of that mud going down. Basically what that is that these fine parts are getting washed through this process that I'm going through, and they're being collected in the bucket down there, and that's the reason for the color of the water seeping through the sieve. So I'll do this in various different portions, and as I see that the water going underneath is starting to clear up in color, then I'll add the next scoop and do the same thing. So I want to give this kind of motion to my hands to make sure that the water goes through all the solid particles here and that all the fines basically get washed. I want to make sure that I collect most, if not all, of the fines that are in this soil. Right? And the result would be that as I get all of the fines out, the water underneath is starting to clear up one more time. So same process until I get all the fines out. And so the resultant at the end of this process will be that I'll be collecting all of the fines part in the bottom bucket, and I'll have all the coarse particles up here, right? Meaning the particles that I'll be testing through the sieve analysis. So one more scoop. So I'm going to continue washing the soil. As you can see, the water going underneath is a little bit more darker now. See, that's because it's grabbing more fines and taking down with it. Once I see it being cleared out, I would add another bit of that. Sometimes you can also use a tool like this, but make sure that you don't get anything stuck in the brush. Alright. Let's go for one more scoop. Maybe we'll do 2 scoops this time. So what I'm looking is that the water coming through the bottom is pretty clear. That's telling me that I've pretty much gotten all the fines. I'll bring it up so you can also see, hopefully, that the water underneath is pretty clear, right? So that's telling me that I was able to grab all the fines of this soil and the bucket below. And in a second, where all the water drains, I'll show you what the underneath looks like. So what I'll need to do is to place all of the coarse particles of the soil, which look like this, in a pan and place them in the oven to get dried. You may actually need to use a little bit of water to collect all of it. So what I have right here is a mixture of the coarse particles of the soil, which you can see right there. So this is all the coarse stuff. I'll put this in the oven to dry out, so basically all the water will evaporate, and what I'll have is a fully dried coarse part for the sieve analysis test. And right in here in this bucket, what I have is the mixture of water and all of the fine particles. So what this is basically not really ready right now to test, obviously, because it's wet. So what needs to happen is first we'll let it sit for about 5-6 days so that all the fine particles that are all now mixed with the water, they would all settle with time and go to the bottom of this bucket. And then what we'll see in a few days is we'll have clear water on top, and then the fine particles at the bottom of this bucket. Then later on what we'll do is we'll grab the fines particles, we'll place them in another evaporating dish and put them in the oven so that they will dry out, and then we will use a sample of the fines part for running the hydrometer test, and we'll test the coarse part using the sieve or the sieve shaker. And then we'll combine the results of the two tests to construct the sieve analysis test or the grain size distribution curve. Alright, so what I want to show you now is how to operate the sieve and the shaker. So here what I have is all of that coarse particles that were retained on the number 200 sieve that we were just washing. So they've been in the oven and dried out, and now I'll be placing them on a stack of sieves that I have right here. This is the stack of the sieves that I have. The number of the sieves are shown in your manual, but they're generally from bottom to top. They're the finer ones at the bottom, and as we go up we have the coarser ones. So at the top we have the number 4 sieve, then we have number 10, number 20, 40, 60, 100, and number 200. And at the bottom we have a pan where we collect all of the fines that were still not fully washed as we were washing, but still in the dry coarse part, and as we run the sieve they'll be collected in the pan. So we'll use whatever's in the pan, again the mass of that, as a part of the analysis for the hydrometer test, which we'll be doing later on. But right now the idea mainly is to grab these sieves and make sure that they're clean, weigh them. We have to weigh the sieves before we run the test. So basically an empty sieve, because as we start shaking the shaker, what's going to happen is that a little bit of soil is going to retain on each one of the sieves. So if we have the weight of the empty sieve or before shaking it, and then we have the weight of the sieve after shaking it with the amount of soil that's retained on top of it, that is how we will be able to construct our grain size distribution curve. So I'm going to show you 2 examples of a coarser sieve where you can see the openings, which are pretty coarse, right? This is a number 4 sieve. Hopefully you guys can see it right there. This is the number of the sieve. So it's 4. That's the number 4 sieve, and the opening is 4.75 millimeters. This is an example of a finer sieve, right? So not a whole lot of space in between the openings, so the openings are a lot smaller. This is an example of a number 35 sieve with an opening of 0.0164 inches, right? So something pretty fine here. So the next step is to remove the lid here. So again, on top of this I have the coarser sieve, number 4. I'll place the soil all on top. You'll see that immediately some of it will go down, right? And some of it will be retained on the number 4. I place back on the lid. Next step is to bring the stack of sieves and place them inside the shaker. So once we have that, we need to place this collar on top so that it secures the sieves, and then we will screw them all up and fasten it pretty tightly so that stuff doesn't move around and doesn't fall out of place. And once we have that, then the next step is to turn on the shaker. So this is all pretty secure and going pretty well. So this is a view from the top of this. So I have that collar, and this is the stack of the sieves, and that's the little motor for the shaker. So let me place this back, and I'll be turning on. Close this door off. This is a pretty noisy device, so what I'll do now is I'm going to turn on the shaker, and I'm going to leave it on for 10 minutes, and then I'm going to come back after 10 minutes and take the sieves off. Alright, so now it's about 10 minutes that the sieve has been running, and I'm going to stop it. So that's 10 minutes. The next step is to disassemble the sieves and take them apart. So now that I have the stack of sieves up, I bring them all out. And the next step is to take the sieves out and now weigh them with the amount of soil that has been retained on top of them. So as an example, I'll try to show you. So this is what has been retained on the number 10 sieve here that we have. Okay, I'm going to try to take this apart. Well, I'll show you the bottom one. This is number 40, and as you can compare the two, right? So this is way coarser than this stuff. Pretty cool, huh? So then we would weigh each one of these and see how much soil is being retained on top of them and record these values. So again, this is our number 60 sieve. So as we're going down, stuff is getting way more finer. Then here we have our number 100 sieve, so a good amount of that, and this is the stuff that's retained on our number 200 sieve, as you can see. And we have a little bit retained in the pan going through the number 200 sieve, basically meaning that we still had some fines that did not get fully washed in the washing process. So with these masses that we have measured now with the scale, we can construct the grain size distribution curve for the coarse particles, right? We'll still need to analyze the fine particles through the hydrometer test and add that data to the grain size distribution curve. All right, so the bucket with our soil and water mixture from the wash of the sieve is now completely clear. The water, all the clay and silt has fallen out of the water column and is built up on the bottom. So now we have to siphon the water out using this tube carefully, and then take all of the soil and put all of that into the oven to dry and then weigh. All right, now that the soil has finished drying in the oven from what we got collected from the wash, here's what it looks like after it's been dried, right? All fine particles. And now what we're going to do is the hydrometer portion of this test.
to do that, we need a hydrometer, which is this device right here. It's a glass tube. It has a bigger volume here at the bottom that'll cause it to float. And here are the markings along it, right? All these markings on it are what in the lab manual are called R sub T. These are the actual markings on that. And so that's what you'll be reading when you are measuring the hydrometer in the soil water mixture. Now, the first thing you have to do is calibrate this. So you'll weigh it first, and then next you'll want to measure the H1 value at each of these major tick marks, which you can do by taking any ruler and you measure from the base of the where it starts becoming a larger diameter here, and you'll measure to each of these major tick marks the value, and then you'll use that when you're reading those tick marks on here to be able to know what the actual H1 value is. So once you have that calibrated, you can begin with the actual test. Now, the actual test involves taking this dried soil, and we're going to mix it with water and some of this this agent that will help to break up all the soil particles. And we put about 5 grams of that along with the approximately 50 grams of the dried soil and water, and we'll be using this mixing cup here that has an automatic mixer on it, and I'll be showing that next. There are dead bugs in here. Alright, I'm going to mix the soil with some deionized or distilled water until it becomes a smooth, thin paste. And then I'm going to wash it into the mixing cup we have here. And then I'm going to add the deflocculating agent along with that. Here's our mixing cup, and here goes the soil water mixture into it. Now, in goes the deflocculating agent. And now, with our cup full of this mixture, we're going to need to mix it using our big mixer here. So first, I'm going to turn it on, turn the power on, and then placing the cup in here. Just starts up and it goes. Now we need to do this for 10 minutes straight. Great, so here's our mixed up mixture. All the particles should be totally torn apart from each other at this point. Okay, now we're going to take that mixture and we're going to put it into this graduated cylinder that has a cap that goes along with it. We're going to wash it in again using distilled water to make sure we get everything in there. And then we're also going to fill up the graduated cylinder to make sure it's all the way up to the 1,000 milliliter mark. So here it goes. And now I need to use the distilled water to rinse out the rest of it here. Really making sure to clean it all out, making sure that everything that's coming out now is clear. Getting all the sides. Great. Now I'm going to go fill this up the rest of the way with distilled water. There we go. We have it at 1,000 millimeters. I'll just get it so that it's right at the mark. There we go. And now we want to mix it up. We're going to do that by putting the cap back onto the graduated cylinder. And we want to thoroughly mix it for 30 seconds. And the best method for doing this is just end over end, like this. And you want to make sure that no more soil is left stuck at either end. So it looks like it's all floating now. There's no more stuck at the bottom or top. So I'm going to put it down and start my timer. And we want to take hydrometer readings in 1/4 of a minute. Which is about right now. Just want to stabilize it there. So it was 10:23. Now it's 10:21. Now it's 10:20 on the mark at 1 minute. And at 2 minutes, it is at 10:16. So now that we hit 2 minutes, we're going to take this out and we store the hydrometer in this graduated cylinder next to it that's filled with distilled water. And we're going to mix it again and we're going to repeat this 4 times. I'm going to put this down very quickly after I mix it and put the hydrometer in so that you can watch the hydrometer as it rises very rapidly or sinks very rapidly after you put it in.
All right, it's been a couple of days, probably around 40 hours since we last made a reading. And now we can see that it's at approximately, let me see if I can point this towards the camera. There's the 1,000 mark, and it's beyond 10. It's about 1, 2, 3, 4, 5. About 1,009 on that R sub T reading. Now, we would want to let it wait all the way until it gets to about the same density as just regular water, which is a little over 1,000. And at that point, then, we'd take all this and we'd pour it out into the evaporating dish and let it dry out. And then we would weigh it again one more time at the end to get the mass of all the sediments that are in this graduated cylinder.
And here's just another view of the entire graduated cylinder after about 40 hours of letting the clay and silt settle out of the suspension in the water column. At the bottom you can see that there's a lot of soil that's accumulated down there, right? It wasn't there before. And overall the color of the water is lighter than when we last looked at it.